Usually in economic theory, we deal with explicitly defined functions or simply explicit functions. Like in microeconomics, the output of a firm is given by a function which depends on the factors of production, labor and capital. Or the cost function, for example, also it depends on the value of the output. But quite often we have to find a function. For instance, let's consider a perfectly competitive firm that maximizes its profit, and the profit pi is given by the formula the price or the output per unit times the output minus the cost function COY. So this is a problem of maximizing the output for the values of the output greater or equal to 0. It's clear how to solve this problem. By differentiation, we have equation, we call it a first order condition. This is an ordinary derivative. And we view this equation as equation defining the output of the firm, and we call, if we are able to solve it for y, then y is a function of the price alone. So here the price is exogenously given, and the firm is a price taker. So the behavior of the firm doesn't affect the price. So the question is whether the output exists as a function of the price. So in order to formulate the problem in general, let's consider a purely mathematical example. This is an equation of a unit circle. And here I draw the graph. This is our unit circle. These are the axes. Here we have 0.1, -1. The question is whether it's possible to solve for y. So we're looking for a function. Y is a function of x. When I ask the question how to find y of x, usually the answer is it's very simple, because we can solve for y by firstly moving x squared to the right hand side, and after that choosing two signs, either plus or minus, in front of the square root. But that will be a wrong answer. Why? Because we're looking for a function, and according to the definition of functions, a function takes one unique value, y, for any x from the domain. Here we have a combination of signs, and we have a difficulty what sign to choose. But if I restate the question asking whether it's possible to solve this equation in terms of y of x, still we're looking for this function near the point. So I'm choosing a point which belongs to this unit circle. These are the coordinates. And to be more concrete, let me choose the coordinates like 1 over the square root of 2, that's for x0, and 1 over the square root of 2, that's for y0. And I repeat my question, whether it's possible to find a function y of x which satisfies, firstly, the given equation, and secondly, if we substitute instead of x 1 over the square root of 2, the value of y will be the same. Then immediately the answer will follow. We need to choose the plus sign then. That's because the given point belongs to the upper semicircle. If I change the point and choose another, which belongs to the lower semicircle, then the choice of the sign will be minus. But this example tells us that in order to find the function as a solution of some equation, we need to be more specific in terms of a point which belongs to the equation. So we would like to solve this equation in order to find y as a function of x. Such a function which is defined by an equation is called an implicit function, defined by a particular equation, or simply implicit function. By its nature, the solution will have a local specifics. That means that we need to indicate a point within the neighborhood of which we're looking for this implicit function. It would be very difficult or simply impossible to answer the question for a Rolle interval of x values stretching from -1 to +1. So this result, how to find an implicit function defined by the equation, is a local in its nature. So it would be impossible to get a solution for this implicit function for all values of x from some interval, for example. But in a neighborhood of a given point, it's quite possible to do so. It's time to state a theorem which will provide conditions under which the implicit function will exist.